Okay. So interpolations, if you still remember, maybe you do some experiment during when you are in school, you do some experiment and then you gather some data. So you have your X value and then this is your function. For example, when you do your experiment in science, you have your data, you collect your data. For example, X is temperature, F here is the distance. For example, you do some in terms of physics experiment or chemistry. This is just an example. So you have the value. For example, when the temperature is around 23, so you get the distance is around 1.2. Maybe in centimeter. Okay, and then you increase a bit the temperature to 24, and then the distance will become to 1.35. Example, and then when you increase another, the distance become 0.80, and then you collect another data, you get 2. So this is just an example. So you have the data, and then your teacher will ask you to do the graph from the data. So you have the temperature, for example, here 23, 24, 25, 26. Then the value around here is 1, just a sketch, not really exact solution. So here you can have 1.2, this value, and this value. All right. So from there, if you still remember, you have your ruler. Sometimes you use your curve ruler to do the graph. Ensure all the data points connected together. So you get the function of this particular data, meaning that if you have different value of X, you also can get the different value of Y or Fx. Okay, so this is the experiment we do in our maybe physics or chemistry class. All right. So how about I want to know the temperature for 24.5. When the temperature is 24.5, what are the distance? So when you draw a graph, you can try to get the answer. For example, you get the value of fx. So this is how we use graph to get the value. But right now we want to use numerical. We want to calculate, because if you still remember, if you want to come up with a good system, normally we cannot see the graph directly. The graph is a visualizations. For human, you can see clearly, but for the computer, they want to know the value directly. For example, if I put the value of x to 24.5, this is x, I get directly my x. What is the, I want to directly calculate the value of fx. Or you want to do a prediction, maybe this one until 26, the temperature is 26. Now I want to know when temperature equal to 30, what is our, okay, so how you get this value? How you get the solution for fx when some data point? So interpolations have the solutions to answer our questions. For example, we have several data points. We can calculate another point is not included in the original data point. So that is what we call interpolations. Clear? Right. So now we move to the method. So you see here, interpolation is the technique of estimating values Okay, value of functions for any intermediate value or independent variables. So what is the meaning of intermediate value and independent variables is like this. We'll find the value of fx independent based on the independent variable. So here the independent variable is x. A set of points of independent variable are given. Okay, so remember, if you want to use numerical method, is not come from zero. It will have some information about the problem. So the information is a set of points, x1, x2, x3. This is what we call point. We have the value of fx1, fx2, fx3. This is what we call a point from the independent variables. Are given which they may arise a measurement in a physical problem. Remember, I show you just now the physical problem is about the temperature and also distance. So we have set of point related temperature and right. So this is what we call measurement of the physical problem. In your case, maybe you have a different problem. Example, air quality. So the measurement is PM10. So we have that measurement to put into our system. Or they may be obtained a known function. In some cases, we have a function. For example, function exponent x plus 2x. This is a known function. So the interpolating function is usually chosen from a restricted class of function, with polynomial being the most common use case. So what they are doing is actually they try to interpolate the point into a polynomial function. Okay, if you still remember when I draw the graph just now, so this is actually come from the data point. We can maybe quadratic. So the graph may be x b plus. Okay, clear? All right, now we move to the method. So the first method is Newton interpolating polynomial. So meaning that from the data point, we want to come up with a polynomial function that can represent the original data point. So normally we just have our data points, and then from the data point we construct a quadratic, linear or cubic. It depends to your problem. You want to come up with a quadratic or cubic or whatever degree of polynomials in order to know or to interpolate the data. Okay, I will move to the example. I don't want to show you the theory part. Move to the example. Okay, so finally, we will have our interpolating polynomial. Right? So this method we call Newton divided different interpolating polynomial. Okay, so I will show you the example first. It's much easier to look or to understand the method from the example. Okay, so first we look at the simple example, meaning that from the Newton interpolating polynomial, we want to come up with a linear interpolation, only linear. So do you remember what is the linear interpolation? Ingat lagi tak linear? Linear is about x equal ax plus b. This is what we call linear functions. The degree of the polynomial is equal to 1. So you see here the degree is equal to 1. This is what we call linear interpolations. Okay, so the simplest form of interpolation is to connect two data points. If we have linear interpolation, we just need to use only two data points. Okay, get to the example here. So in this case, I have how many data points? I have 4 data points. To use linear interpolation, I just need 2 data points. No need to use all of the data points. Only 2 data points. Because we want to come up with linear interpolation. Linear is a straight line. So this method we call linear interpolations. Okay, linear interpolations. And the linear interpolation formula is given by this. So you have, if you still remember, you just going up here. Linear interpolation meaning that now your n is equal to what? N equal to 1. Okay. So when you have n equal to 1, so you have f1 x plus fx naught plus x minus naught times f x1 x naught. So stop until here because you just have 2 data points, x naught, x1. If you want to move forward to two quadratic interpolation, you need to have 3 data points, x naught, you see here, x naught, x1, x2. If you only have 2 data points or linear, you just have x naught, x1. So x represent the data point. Okay. So you have to calculate, for example, here fx naught, you have the value. X and x naught, you have the value. So you have to calculate this function. F in bracket x1, x naught. So these functions, how you calculate this function? So actually this function, we call it as a B. B1. B naught is fx naught. B1 is fx1, x naught. So how to calculate B1 is, this is the formula. Okay, the formula is actually using first order interpolating polynomial. So fx1 minus fx naught divide x1 minus x naught. Actually the formula of slope. Remember, sorry, slope. Slope. Okay, what is the formula of slope? If you still remember, y2 minus y1 divided by x2 minus x1. So this is the formula of slope, or we call it as a kecurunan, if you still remember, slope or kecurunan, or what are the names for slope. So this is actually the same functions. Okay. So the notation of f1x designated that is the first interpolating polynomial. The term b or this one is representing the slope of the line connecting the point. Actually formula ni datang daripada formula untuk kita draw linear graph. Okay, so in general, smaller interval, ni remember the tips. Between the data point, better approximations. This is due to the fact that as the interval decrease, the continuous function will be better approximate by straight line. Okay, so now we look at the example. Remember, linear interpolations, you just have linear functions, so you need to find the slope. Ni kan selalu slope for the linear function. Okay, look at the example. So now you have to estimate natural logarithm of 3. So natural logarithm of 3 is ln 3. Don't use your calculator. We have to estimate using Newton method, using linear interpolations. Okay. So first, perform the computational by interpolating between ln 1 and ln 6. So the first data point is ln 1. The function is 0. Ln 6, and then the function is 1.791759. Okay, so then you want to put into your formula for linear interpolation. So this is actually the formula for linear interpolations. Okay, so you have your fx, x1, y1 because linear, equal, so you will use fx naught plus, so this one just now is your, what? It's actually your slope, and then x minus x naught. So how you calculate the slope? So you have to use the value given or the data point given. So fx naught is 1.791759 minus fx naught, sorry, fx1, fx naught is 0 over x1, x1 is 6, and then x naught is 1. Look at the formula down here. And then use your calculator, then you get the value of fx. 1 for ln, meaning that when x equal to 3. Okay? So this value x replaced by value 3 because this is the one that you need to find. Okay? So next, you have another second question. You need to use another set of data point. This is your first data point. This is your second data point. So your second data point is x equal to 1. So the value is 0. When x equal to 4, the value is 0.38629. Alright. So you do the calculation using the formula, this formula. Okay, for linear interpolation. So you have your fx naught, this is actually fx naught is 0 plus, okay, this is the formula, fx1 minus x naught over x minus naught times x. Your x is equal to 3. So in this case, x equal to 3 minus x naught equal x1. Okay, minus x naught. So finally, you get the answer. So this is actually the answer. Okay, so which answer is what we call that is more accurate? So you need to calculate the error. As usual, remember, numerical method, we have to calculate the error in order to see whether our answer is good or not. So this is a program for ln 3 is equal to 0.716736. This is also another approximate solution. When ln 3 is equal to 0.9296. So you have two different answers because you are using two different sets. So look at next, the true answer is when you use your calculator, when you look at the calculator, the answer is 1.098612. So the answer is what? 1.09. True answer is 1.098612. So you can see which solution is near to the true solution. So you can calculate. from our eyes, we can see that the second approximate is quite near to the true solution. Why? Because the interval is near. This one, the interval from 1 to 6. So the size is 5. This one from 1 to 4, the size is 3. So if you look at the last point here, in general, a small interval of data point, better approximation. So this is the key point. So normally, make sure we use a small interval. So the answer should be close to the real value. Okay, any questions? Any questions so far? Boleh faham tak? Okay. Any questions? Okay, kalau tak ada soalan, kita try to do the extra activity. Okay, try to do the extra activity. So now, you have to do together with me. I give you some times, you read the questions and then try to answer. I will explain again after 5 minutes. So I give you around 5 minutes to see the questions and then to try to see how I can solve this problem. So remember, in some cases, they give you the data point. This is actually the data point. Okay. And then they ask you using linear interpolation to estimate this. Exponent negative 0.912. So in this case, the function is actually exponent negative x. So no need to put negative inside your x because this is actually the function. So now you have to use your linear interpolation to calculate for x equals 0.912. So which interval should be the best choice for your interpolations? So you can use from x1, x0 equal to 0.90, x1 equal to 0.91. Can you use this interval to calculate your Newton interpolating polynomial? What is the answer? Boleh tak guna interval ni? Cuba jawab dalam ni. Dalam chat. Or you boleh buka you punya unmute your mic. You can use this or not as your interval. Okay? Can you use this interval? So I can see some answers from the chat. Yes. So, no. Of course, this is not the right interval because the point that you want to search for the value of fx is 0.912. So it's not belong to this interval because we have 0.90, 0.91, and then 0.912 is here, not inside the interval. So good. Thank you for those who answer to me. So interval is 0.91 and 0.92. So this is your x0, this is your x1. Okay, actually you can use 0.90 and then x1 is 0.92. But this is not the best solution because the interval size is bigger compared to the best so far. Based on that given. Okay, so now you can move to your next step. After you have your interval, it's the first step. Second step, use your formula. So what is the formula? So fx1 equal fx naught. What is the formula? Minus or plus 1 minus x naught over x1 minus x naught times with x. This is the formula. So try to do the calculation. I give you minutes and then share with me the solutions. Okay, give you 5 minutes and then share with me the solutions. What is your solution? Hopefully everybody do the calculation. I want to see all of you answer me from the chat in our WebEx. Answer to me the solutions. What you get when you do the calculation. Although there is an answer here, but you have to do your calculation and then share with me your solution. Maybe you can do 5 decimal places. Take 5 decimal places for your answer. Okay, give you 5 minutes. Try to solve the equation given. Okay, what is your solutions? Please share in the chat box.